Hi everyone, welcome once more to this YouTube channel, Best Science Brain YouTube channel. Today we are taking a physics content, an experiment on physics, practicals involving a glass block, rectangular glass block, and a plane mirror. So you look at the title of the experiment that says refraction involving rectangular block and a plane mirror. So if you are not subscribed to the channel, the video is playing right now. Move up to the channel's subscription bell or icon under the video, tap on it and get subscribed for more videos. So we're not going to run a live experiment. That will be for another day. But in this particular experiment, we're going to show how you can obtain your values theoretically, how you can do this experiment without touching any equipment, or how you can aid yourself using theoretical principles, using mathematics and physics principles to obtain what you want, to obtain a nearly perfect result. So let's look at the rectangular prism. You have the outline A, B, C, D. They have two numbers drawn on it, ON and O prime N prime. You see the numbers are extended to make an angle theta below the face AB. The distance between the two numbers is small letter d. You see the incident pins P1 and P2. You see the pins following the emergent ray P3 and P4. You see angle I between the incident ray and the number NO, that angle of incidence. You also see E, angle of emergence between the number O prime and M prime and the angle or line of emergence. So let's read the equation before we now start talking about the manipulation. So you're provided with a glass block, plane mirror, and optical pins. I place the glass block on a drawing sheet and trace its outline A, B, C, D as shown in the diagram above. To remove the block, measure and record the width of the block. Look at the diagram. The width is, you can see there, W from A to D is the width. So every prism has its own size. For our own prism, you can see there the width of our prism have been measured and is 6.5 cm. The width of our prism W is 6.5 cm. Triple I, draw a number ON to DC at a point about 1/4 of the length DC. So DC is this face. The number ON is drawn, look at the number ON, is drawn 1/4 the length of DC. So you measure your DC, find 1/4 of the length DC, and then draw the number ON at that point. Let's continue. Okay, number IV, draw a line making angle I 10 degrees with the number V. Replace the block on its outline and mount the plane mirror vertically behind the block such that it makes good contact with the face AB. VI, stick two pins P1 and P2 on the line MO. VII, look through the face CD, stick two other pins P3 and P4 such that they appear to be in a straight line with the images of pin P1 and P2 seen through the block. VIII, join P3 and P4 with a straight line and extend it to touch the face CD at O prime. IS, draw a perpendicular line from the midpoint OQ to meet AB at Q. S, draw lines OQ, O prime Q, and number OM prime produced. SI, measure and record theta, E, and D. SII, measure, evaluate M equal to sine E and n equal to cos theta over 2. SII. Repeat the procedure for I, 20 degree, 30, 40, and 50. SIV, determine the slope S of the graph and evaluate Q equal to 2S. SV, say 2 precautions taken to ensure accurate results. Attach your traces to your booklet. So we have read out the questions, or we know what we need. What are we measuring? We're measuring angle I. No, angle I is given to us. The angle I are the angles of incidence 10, 20, 30, 40, 50. We're measuring angle theta up there. We're measuring the distance D between the two normals in each experiment. We're measuring the angle of emergence. So in this, as I said, we are not going to do an experiment. We're now going to see how we can do the calculations. So here we are on the whiteboard or in the laboratory trying to look at this and then investigate how we can obtain our values by calculation. So this is the diagram that we have, which I showed you earlier on. Have your plane mirror, AB, have the line of incidence, the angle of incidence is there, I. You have the normal, NO, drawn after the incident ray is drawn to meet the face AB at this point, Q. Reflected ray, because there's a mirror here, the reflected ray. So this is going, but this one is coming out. Reflected ray, and then normal, M prime, Q prime, and then the emergent ray, this is E. Now, for us to be able to solve or obtain our values, which we are looking for each set of experiment, we need to understand certain principles here. Then, what do we need to understand? Because this law is all about proving Snell's law of, this experiment is all about proving Snell's law of refraction. So, the first thing we need to know here is that we need to calculate the angle between the normal and the reflected ray. The angle here, R. Let's call it small r. Angle between the normal and the reflected ray. They call it R, angle of reflection of the light inside the glass. So we have to do that. To do that, so I call the angle here R. To do that, we apply Snell's law for two different media, which says N1 sine theta 1 equal to N2 sine theta 2. So now N1 refers to the refractive index of air, N2 refers to the refractive index of glass. So we're going to replace this theta 1 with sine I, that angle of incidence in air. We'll replace theta 2 with sine R, which is the angle of refraction inside the glass. So we now have a modified formula. N1 sine I equal to N2 sine R. Okay. So we can see the formula on the board. N1 sine I equal to N2 sine R, where N1 is refractive index of air, which is always approximately 1, and then I is the angle of incidence. Then N2 is refractive index of glass. For a glass block, we're taking approximately 1.5. You can still use 1.51 on your own, 1.52, 1.53, but don't exceed 1.6. More than 1.6 could be critical. So we'll have 1.5 here for this glass. Then we also have R. R is the angle of refraction of light in the glass, which is what we want to calculate. Remember that this R is not given in the question. We just created this R here. Now from here, let's make sine R the subject. So sine sine r equal to now n1 sine I all over n2. So that is the value of our sine r. Then from there we can now find the sine inverse of r to get our angle of refraction. That is good. So we need this equation to work. We call it equation 1 to work. Then another thing we have to measure is this angle theta. Now if you look at this line AB is parallel to the line DC. So if I remove this theta here, the angle made here will be equal to r by virtue of alternate angle. The two angles are equal by virtue of alternate angle. So the angle of incidence here is r. The angle of reflection, remember that there's a mirror, so that will have reflection going back. The ray could not penetrate, it now have to go back. The angle of reflection here is also the same r. By the law of reflection, the angle of incidence is equal to angle of reflection. That means our theta here, which we're looking for, our theta will now become equal to 2r. So our theta will be equal to 2r. So this is also another one that we need. So when we get our r, the essence of getting this r is for us to calculate theta. So we'll get r, multiply r by 2, we get our theta. Having done that, so this line moves straight to the face DCD. How do we now get angle of emergence? Angle of emergence here is an angle of incidence here are equal. I repeat, the angle of emergence and this angle of incidence here should be equal because what happened here is just reversibility of light. So the two angles should be equal to each other. So if I here is 10 degree, our E here is also 10 degree. So with this little explanation, we are seeing how we can obtain our I. So I is given, obtain our theta. First of all, you have to get your R. Using this formula, you get your R. After getting your R, then 2R will give us theta, which is the angle at the middle here. Then the emergence and the incidence should be equal to each other. So the angle I is known, theta can be calculated, E can also be estimated because E and I should be equal to each other. But for the sake of practical, we are this is a practical question. This is not purely theoretical question. So we know that I and E are equal, but you have to slightly change E by a little difference of 0.5 or 0.3 or 0.2, so that it will be that this is done by experiment, because experiment you expect human errors to come in. So you should not make E, like if my I is 10 degree, I can make my E to become 10 point. If my I is 10 degree, I can make my E to become 9.5 or 9.6, a slight modification. So now we have seen how we can get the whole angles. Then what remains is to find the D, the distance between the two different normals. So we're going to get this D when we do the construction, when we do the tracing, we can now get our D. So let's do the calculations right away. So here we are on the calculations. For us to do the calculations, we have the table. We need these values, I, theta, E, angle of emergence, M equal to sine E, that evaluation we're going to do, N equal to cos theta over 2, and then D in centimeter. To find our theta, we'll go to our rough work and calculate R, which I gave you today. I said that sine R is equal to N1 sine I all over N2. This is the formula we got a few minutes ago. So for the 10 degree angle, remember that N1 is the index of air, which is 1. We'll now take 1 times sine 10 all over N2 with the index of the glass block 1.5. So when we solve that, sine 10 is 0.1737. Well, I have 0.1737 all over 1.5. Then our sine R, solving it, divide 0.1737 by 1.5. That gives us 0.1157. So 0.1157 as this when you evaluate this. So our R becomes sine inverse of 0.1157. Find the sine inverse of 0.1157, and that gives us approximately 6.644 degrees. Then theta, as we said, I said that theta is obtained by using this angle by using 2 times R, which is 2 times 6.644, and that gives us approximately 13.3 degrees. Approximately 13.3 degrees. So we'll go up here and report theta as 13.3 degrees. You see that? We repeat the same process for sine 20, the next angle. I wipe. For sine 20, the same formula. Replace ni1 with 1, the index in air, then times sine 20 all over 1.5 with the index of the glass we're using. So that becomes 1 times sine 20. Sine 20 is approximately 0.3420. So 0.3420 all over 1.5. So when we divide 0.3420 by 1.5, we'll be getting a 0.228. 0.228. Then R becomes sine inverse of 0.228. So when we do that, we're going to get sine inverse, we're going to get 13.2 degrees. So 13.2 degrees. So theta is 2R, which is 2 times 13.2, that gives us 26.4 degrees. Write theta here, 26.4 degrees. You see, it appears to be increasing. This is increasing also. So when I pick sine 30, the third angle, incidence of 30 degrees, we wipe this side. When I have n1, 1 times sine 30, all over the index of glass is 1.5, which should be 0.5 all over 1.5. So sine 30 is 0.5. So when you divide 0.5 by 1.5, you get 0.333 to 4 figures because you're using the 4-figure table. So when I find R becomes sine inverse of 0.3333. So when you do that, you're going to get 19.5 degrees. 19.5 degrees. Theta is your 2R, which is 2 times 19.5. That gives you 39 degrees. So here is 39.0 degrees. So, having done that, we'll now go to the next angle, which is angle 40 degrees. Then when I is 40 degrees. So if I is 40 degrees, how do we evaluate that? The same process, substitute the index of air 1 sine 40 all over 1.5, the index of the glass block. So sine 40 is equivalent to 0.6428. So now I have 0.6428 over 1.5. So sine R will now give us, we divide 0.6428 by 1.5. You're going to get 0.4285. 0.4285. So our R becomes sine inverse of 0.4285. So use your calculator and evaluate that. And that gives us 25.4 degrees. 25.4 degrees. Theta is 2R, which is 2 times 25.4 degrees. That gives us 50.8 degrees. Right here, 50.8 degrees. Degrees already there. So we'll now go to the fifth angle of incidence, where our I is 50 degrees. Our I is 50 degrees. So what do? We replace of course, N1 is 1 index of air times sine 50 over 1.5. So find sine 50. Sine 50 is 0.7660. 0.7660 all over 1.5. So we'll divide 0.7660 by 1.5. We'll be getting 0.5107. 0.5107. Find the sine inverse. Sine inverse of this, that is your R, is sine inverse of 0.5107. When we do that, we'll be getting 30.7 degrees. 30.7 degrees, yeah. Then find theta. We're getting our R. Theta is 2R, which is going to be 2 times 30.7 degree. That gives you 61.4 degrees. 61.4 degrees. So you write 61.4 over there. So having done that, you fill the column for I and the column for theta, getting some good results. So having done that, we now find our angle of emergence. As I explained in the earlier part of the video, I said that the angle of emergence and the angle of incidence in that diagram are equal to each other. The angles of emergence and incidence are equal to each other because the ray was just reversed. So we don't have time to start calculating to prove that, but it can be proved by calculation. The ray is now moving from glass to air. So E and I are equal, obeying the principle of reversibility of light. So having done that, we are going to list the angles of it. So we're supposed to list 10, 20, 30, 40, 50 here. But for the practical aspect, this is a practical question. It's not something that is theoretical. So there's bound to be human limitation or human error in this practical. So we're going to adjust this one a little to get a value close to it but not actually equal to it. So what do? So in this video, I'm going to subtract 0.5 from each angle of incidence, 0.5 from each angle to get the angle of emergence. I just take 0.5 as a limit of error. So you subtract 0.5, you have 9.50, subtract 19.50, 30 minus 0.5, 29.50, 40 minus 0.5, give us 39.50, 50 minus 0.5 give us 49.5. So 9.50, 19.50, 29.50, 39.50, and 49.50. See, they're approximately the angle of incidence. So we have to do it that way so that it will look like a pure practical question. A practical exercise, sorry. They will now find sine E. This is an evaluation we're asked to do. So we're not measuring these ones. You find sine of each of this angle of emergence. Sine of 9.5 will give us 0.1650 to 4 SL because you're working with a standard 4-figure or table. Then sine of 19.5 give us 0.3338. Sine of 39 give us, sine of 29.5, not at 29.5, will give us 0.4924. See, you're gradually filling your table. Sine of 39.5 give us 0.6361. Sine of 49.5 give us 0.7604. So 7604, we've done that. We'll now go to the next column. We have to evaluate the letter N. We want to cos theta over 2. Cos theta. Theta is this angle. So for each of them, like for this, the first example now, we want to evaluate cos theta. Remember that bracket covers theta and 2. So what I'll do is I'll replace 13.3 by theta over 2. and find cos of D. That will give me cos, this is around 6.65. I'll find cos 6.65. If I do that, I'll be getting 0.9933. So you do that. Repeat for the second one. So here, replace 19.5 theta. Okay, theta is 26.4. Sorry, 26.4 second one over 2. We're gonna have cos 13.2. If you divide by 2, cos 13.2 give me 0.9736. Okay. For the third one, the third row, our theta is 30 degrees. Our theta is 39 degrees. So you now find cos 39 over 2, which is cos 19.5. I hope you know what these angles we're getting represent. These angles we're getting are the things you cannot get by the experiment. Actually, we got them by calculation. That the angle or refraction we will multiply by 2. We're getting them back. So cos 19.5, and that will give us, for the third column, 0.9426. Then, for the fifth column, our theta is 50.8. Of course, 50.8 over 2, that gives us cos 25.4. When we do that, that gives us 0.9033. Okay. Then we go to the fifth one, the fifth row. Our theta is 61.4. Replace theta with 61.4 and divide by 2. We'll have cos 30.7. Let's confirm the calculator. Yes, cos 30.7 will give us 0.8599. So we'll have a complete table now. A complete table. So when angle incidence is 10 degrees, theta is 13.3, emergence is 9.50, sine of emergence, sine of 9.5 is 0.1650, then n cos theta over 2 give us 0.9933. When I is 20 degrees, theta is 26.4, emergence 19.50, sine of emergence, sine of 19.50 is 0.3338. Then cos theta over 2, remember that theta is 26.4 here. That because 13.2 gives us 0.9736. When I is 30 degrees, theta is 39 degrees, emergence 29.50, sine E, that is sine 29.50 is 0.4924. Cos theta over 2, theta here is 39. So put 39 here, cos 19 over 19.5 give us 0.9426. When the incidence is 40 degrees, theta is 50.8, emergence is 39.5, then sine E, sine, that is what M represents. Sine of emergence sine 39.5 is 0.6361. Then cos theta over 2, theta here is 50.8, that is cos 25.4, theta over 2 is 0.9033. When incidence angle is 50 degrees, theta is 61.4, and then emergence is 49.50. Then sine E, sine of angle of emergence is 0. Sine of 49.5 is 0.7604. Cos theta over 2, theta here is. So we have these values here. So now we're going to do our tracing, where we're going to trace these angles as required in the experiment, and then from the tracing we get our D, the values of D. You know that in this kind of experiment you're supposed to submit your traces, so you don't have to, because the angles have to be measured and to be accurate. So we have to do the tracing and then get the values of D. So that whenever somebody measuring it, he'll be getting the same values as if it's a live experiment. So we have to trace the outline. This is a rectangular prism. We have done the tracing A, B, D, C, D. The width of the prism AD have measured W as 6.50. That is this width or length, as you can call it. Then, as we are told to do an experiment, we should make our normal at a distance 1/4 of DC. So measure DC, and DC gave us 10.4. Divide 10.4 by 4, we have 2.6. So from here to there is 2.6. Having done that, what then do we do? We're going to make our normal there. We'll keep our protractor, making sure the baseline of the protractor covers the line DC. They will mark angle 90 here, and they will draw a straight line. Draw a straight line. There's our normal. So that number is our NO, according to experiment, NO. Then we're now going to make angle of incidence of 15 degrees. To make 15 degrees, we put the protractor in the opposite direction, making sure that the baseline is covered. There is our 90. So mark at 15. So from 90 to 100 is 10. Then half, middle is, okay, it's 10 degrees. The incidence is 10. So 90 to 100 is 10. So mark our incidence here is 10 degree. So let's get it right again without mistake. So we have it. So here is 10, correct? So we'll now draw the incidence ray, and then we'll move it to the point of incidence. That's 10 degree. So having done that, we put an arrow show that is going forward. Then we'll now look at our reading. The theta is 13.3, and as we say, theta is 2r. So if theta is 2r, our r now becomes theta over 2, which is 13.3 over 2. That gives us 6.65. So we're going to measure approximately refraction of 6.65 here. So put a protractor again, and then we'll read 6.6. So here is 90 to 95 is 5 degree. Then 6 can put it around between 6 and 7. That gives us 6.65. So having done that, we'll draw a straight line from there to hit the face AB, making that angle 6.65. Then having done that, we put our normal protractor again. So on the opposite side of AB, see that the baseline cover. Look at 90 degree. We'll mark 90 degree. So that I can create another normal here. So create another normal. Draw a straight line. So the angle here should be 6.65. Then what do? We'll now put our normal here. Yes. Make it okay. No. The baseline should be covered. So what's your baseline? So this is 90. So read also under 6.65. So this is for 90 to here, middle is 5. We read under 6.65 around here. So having done that, we'll draw a line from that point, cutting across. So that means the angle here, theta, 6.65, theta will now be approximately 13.3. That is 6.65 times 2, 13.3. Having done that, we'll now create another normal here. At the point where the ray hit this point, we create another normal. And that should be, this first number is ON, this one is O prime N prime. Then the angle of emergence is 9.5. So we'll put our number here once again and read off 9.5, which is approximately 10. So here is 90 to 80 is 10. So 9.5 should be between 9 and 10, somewhere here. We'll now draw our emergent ray coming out. So have it here. So this is the angle of incidence, this is the angle of emergence. So our I here is 10 degree. Our E here is 9.50, theta 13.2, and here is our Q according to the diagram. Then we have to measure D. D is the distance between the two normals. So we'll put our ruler here. So this is a half meter rule. Here is 15. And this point is 16.6. So 16.6 minus 15 gives us 16.6 minus 15 gives us 16.6 minus 15 gives us 1.6. So for this one, we'll put our reading. The value D is 1.60 for this first experiment, 1.60. So let's go to angle 20. When I go to the second experiment where the incident angle is 20 degrees, repeat the same process. So we have traced the outline from the prism. The length of the DC is 10.4, as I said. Then 1/4 of it is 2.6, which is here. We place our protractor there, covering the baseline very well, and then marking our normal 90 degree. Then you draw it, your normal, making it straight, 90 degree. Then we'll now create an angle of incidence of 20 degrees. So we'll have here, this is our normal, 20 from here to there is 10. So 20 is from 90 to 70. So 90 minus 70 is 20. We'll mark it at 70 degrees. So 90 minus 70 is 20. So having done that, you draw a straight line to create angle 20 incidence ray. So it's 20 now. Then to get a refraction, we'll go to the table again. Theta is 26.4. And as I said, R is theta over 2. So since that is 26.4, our R will now become 26.4 over 2. And that gives us 13.2. 13.2. So we're going to bring the protractor again. Put our angle 90 on this face. And mark at angle 13.2 on this side. So this is 90 minus 80 is 10. 13.2. This here 13, 10, 11, 12, the third line around here, 13 degrees. So having done that, remove the protractor, draw a line from the point of incidence crossing that place that was spotted to be 13 degrees or 13.2. Having done that, we put an arrow showing the ray is going forth. Then we put the protractor back again. Then, having done that, we'll mark our normal, cover the baseline very well, mark your normal. And also you can see mark under 13.2 this side. So what I was saying here, from here to here is 10. You mark under 13 around here so that you can do it without waste of time. So we'll draw our normal, a straight line from here or a bisector. Then the 10, 13.2, the two angles are equal on both halves. 13.2. So that means theta here, the whole angle here, theta, should be 26.4. So this place now, you now put your protractor, mark 90, the baseline covered very well. and then draw under normal here. Then you want to find the angle of emergence. The emergent angle here for 20 degrees is 19.5. So you bring your protractor back again. Here, cover the normal and mark 19.5. So here is 10. 20 is be close to 20. So 90 to 70 is 20. A line or the line between 19 and 20. So mark it there. And then that'll be 19.5. We'll now get our ray, emergent ray coming out. That will shooting out. So our E here is 19.5 degrees. So these are Q. Then they measure the distance between the two normals. Here is 15. Another one is 15 and then 18.2. So 18.2, I'll come again. Okay, 15 and 18.2. 18.2 minus 15 gives us 18.2. Minus 15 gives us 3.3. Record here 3.30. So this is a diagram for the 20 degrees. And of course, I forgot, you have to perforate this. Let me call here, perforate here with your pin. Call here P1. As a precaution, leave a distance of about 4 cm. This is here, this is 4 cm from 30 to 26. And perforate on that pin. And call here P2. Perforate somewhere here and call here P3. Perforate somewhere here and call here P4. Do it all through the experiment. Let's go to the next angle. So we're constructing that of 30 degrees, incident angle of 30 degrees. This is our outline. And this is our 2.6, which is 1/4 of DC. DC is 10.4, as we said before. So bring our, without waste of time, bring our protractor. Cover the baseline with the line of the protractor. Then mark your 90 degrees. And I can, if I don't want to be fast, I'll say mark my angle of incident, which is 30. So 90, 60, 90 minus 60 is 30. So here should be 30 degrees. So you can do it at once without waste of time. 90 minus 60, 30. So this is your normal. This is angle 30 at 60. 90 minus 60, the whole of this angle is 30. Remove it. And then draw your normal. That is here. Draw your angle of incidence at the same time without waste of time to be faster. So it's going forward to the glass. Then we'll now go to our diagram again, to the table again. Our 30 degrees, theta is 39. We get our R. R is 39 over 2, which is 19.5. So half of this. So we move again with our protractor. Put it here. Cover the baseline of the prism. Then and mark 19.5. So here is 1110 minus 90 is 20. 19.5 will be a line between 20, 19 and 20. So we can put it here. Having done that, I remove it. Then I draw my line from the point of incidence passing through that marked point. You see that going without waste of time. You have that. So you put an arrow showing it's going forward, you're going forth. Then you bring back your protractor and put it in the opposite direction. Cover the baseline. I want to draw a normal. This place is my normal. I also mark under 19.5. For 90 to 70 is 20. 19.5 should be a line before the 20th line or in between. I mark under 19.5 here. So I'll draw my normal. Here it goes down. Then I move here. The reflected ray to pass through this place. You see that? So the whole of this angle here is angle 39 theta. So having done that, you can put your ruler without using. You can put a ruler here and draw a straight line, or you can use the protractor. If you can get a straight line, that is a normal. That was of time. Then you put your protractor here, cover the base very well. Then 90-degree be there, so you can see this 90-degree covers this, and then the baseline covered. You measure the angle of emergence. The angle of emergence for this, the third row, is 29.5. So you can see from 90 to 30 is 90 minus 30 is 90 minus 60 is 30. 29.5 should be close to the 60th mark here. So you put it here, and then you join from here to the prism. So, and then the angle of emergence here, this is your E, which is equal to 29.5. This is your I, which is equal to 30 degrees. Then use your pin and perforate to position. You put, this is your P1. You leave a distance of 4 cm under pin here and here. So you can call here your P1, here your P2, P3, and then P4. Measure the distance from this number to this number. Let's get it right. Here is 15, and here is 19.5. So 19.5 minus 15 gives us 4.5. So this distance is 4.50 for this. So you can see the diagram once more. Here is your Q. And this arrow is going out. You put this one is going out, and the arrow is going out, while this one is entering. So we're going to the fourth angle, incidence of 40 degrees. The prism outline have been drawn out or traced. Then this is 10.4. 1/4 of it is 2.6 ds. So remember that, of course, here should be D, here should be C. Let's correct the error, D and C. So now we'll mark our normal here, put our normal here, cover the baseline, and get your normal. Good, which is here. Also, the same time, you can see create a 40 degree, so you don't have to waste time. So 90 minus 50 is 40. Here is 50, so you mark at 50. So the whole of this angle here become 40. 90 minus 50 is 40. So having done that, you now draw your normal at this point, a perfect straight line, and then you draw your 40 degrees, this line, with the angle of incidence. So the ray is entering, so the angle here, I, is 40 degrees. Mark it. So we're now going to draw the angle of refraction for this experiment. Our theta is 50.4, half of 50 refraction. So divide 50.8, sorry, not 0.4, 50.8 by 2, that gives you 25.4. So 25.4, you're going to create it here. Put your normal here, and then create 25.4. So here is 90. 25.4 should be, this is 20. 90 minus 70 is 20. Then the midline 25. I can mark it at between 25 and 26 line. So call it 25.4. So having done that, I will now draw a straight line going from here to hit the prism. Okay, I'll do that. So having done that, I'll put my protractor once more here to mark a normal again. The baseline covered. This is 90 degree. I get another 25 point, which is 20, 25, 25.4 somewhere here. So I have it there. Then I'm going to draw my normal line. And also draw my angle of 25.4. That is it. So the whole of this angle here, theta, will give us 50.8, 25.4 times 2, 50.8. So having done that, I can draw a straight line here as my normal, or I use a protractor mark 90, or I get a perfect straight line. That's a normal. Then when I've done that, then with my protractor, I create the angle of emergence. Angle of emergence for this one is 39.5. So with my normal here, and then covering the base, 39.5. So 90 minus 6 is 30. I'm talking about 39. So 90 minus 50 is 40. 39 should be close to 40, which is the angle here. Then I'll move this to create my emergent ray. So you put your outgoing arrow. Then this one is going inside. So the emergent angle here is 39.5 degrees. So here is your Q. You perforate here to be your P1 with your pin. Perforate here with your pin to be your P2. Perforate here to be your P3. And perforate here to be your P4. So the diagram you need for angle 40 degrees. Then the next thing is to measure the distance between the two normals. So here is my 15 cm. And here is my 21. Here is 21.1. So 21.1 minus this 15, since this rule didn't start from 0, that one I'm subtracting. 21.5 minus 15 give me 6.5. So I record here for 40 degree the column 6.50. The fifth one, where incidence is 50 degrees, and then there is 1/4 of the phase DC, which is 2.6. So here we're going to create our normal. Put your protractor very well. Then the baseline of the protractor cover the line DC. So you're not seeing the line DC because the line of the protractor covers it. Then mark your 90 degrees here. The angle is 50 degrees. So mark 50 degrees at once. 50. Why do you get 50? At 40. 90 minus 40 is 50. You mark it here. So having done that, you then draw your normal. Keep your hand straight. Okay. And then draw the angle of incidence, which is 50 degrees. So you put here, you perforate here, P1, use pin and perforate 4 cm distance from this, called the P2. Having done that, we'll do for the angle of refraction for 50 degree. The angle of refraction, divide theta by 2. This theta is 61.4. So divide 61.4 by 2, as I've been doing other ones. That gives us 30.7 to give us the angle of refraction. And then you know that all these things you should be doing it on your rough work. So 30.7, you now come to this point. Here is the normal. Here, then mark 30.7. 30.7 is around this point. This 30.5, 0.6, this 0.7 around this point. Okay. So 90, and then 90 minus 6 is 30. This is around 30.7. Having done that, you draw your angle at 90 degrees. So to get 30.7, you bring your normal here, and then here is 90 degrees. You also mark another 30.7. But if you look at this, if you 30.7 is almost going off from the prism, so you have to reduce your hand, so that you will be inside the prism, and then you can see adjust your table later. So I'll reduce it so that the light ray will pass through the prism. So having done that, I'll now have this. drawn, and then draw a straight line by setting the angle made there. Then, having done that, I can now draw my angle of emergence. My emergent angle here is 49.5. So I'll get my normal here. 49.5 should be so far away. This is 40. 90 minus 50 is 40. And 49 should be close to 50. So I'll put it here. So I'll draw my normal here. And then I'll draw the angle of emergence, which is 49.5 on this direction. So my E is 49.5 here. My I here is 50 degrees. I use the optical pin and perforate two positions here and call here P3, call here P4. The angle theta here should be remeasured, but let me see, take it I want to have here. Theta is 61.4. But if you remeasure it, that means you have to make some changes on the table, and then also this side. So 61.4, assuming. Then measure the distance from here to the other is at D. Here is 15 degrees, 15 cm. I'll just start from 15 to measure. And here is 22 cm. 22 minus 15 gives me 7 cm. So now I have 7.00 centimeter. So you can see our table. We have the displacement for the 10 degrees is 1.6. For the 20 degree is 3.30. For the 30 degree is 4.5. For the 4 degree is 6.5. For the 5 degree is 7.0. So it's increasing uniformly. So we'll now go to the graphing. So we want to plot our graph now. We are plotting a graph of M, that is sine E, on the vertical axis, against N, that is cos theta over 2 over on the horizontal axis. So look at the scale that we choose for here. The higher value of M is 0.7604. The least value is 0.1650. So we'll have to choose 0.1 each bus, 0.1, 0.2, 0.3, 0.4. That means each bus to 0.1 unit or 2 cm to 0.1 unit. Then we'll have the N axis. The higher value is 0.99. The least value is 0.8599. So we'll have to start 2 buses for 0.85, and that 2 buses we'll keep on adding 0.05. 0.85, add 0.05, I have a 0.90, add another 0.05, I have a 0.95, add another 0.05, I have 1.1. So we're going to plot now first. So for the let's start from any. So for the to plot now, we have to find the value 0.99. Then I will put into 2 decimal places, 0.99 on the horizontal axis. So here is 0.95. Here is 1.0. The interval between 1.0 and 0.95 is 1 minus 0.95. 1 minus 0.95 will give us 0.05. So that means from here to here I have 0.05. To know what one line represents, I divide 0.05 by 20, since there are 20 lines from here to there. And that gives me 0.0025. So I want to locate 0.99. Now, if I can't see from this 0.95, if I count 16 lines forward, multiply that 16 lines by 0.0025 times 16, that gives us around 0.04. 0.04 plus this will give us 0.99. So we count 16 lines from here. This is 10, 11, 12, 13, 14, 15, 16. But this is 0.95. So here is 0. Now this is 0.99. So we are plotting 0.99 against our M, and M is approximately 0.165. We move up against N. First of all, they get 0.165. So for this line, 10 lines here, each line is 0.01. So 0.11, 12, 13, 14, 15, 16. So it's between 16 and 17. So we move up. These we count it very well. From here, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. So it should be here, 165 against 99. So having done that, we also go to the next. Well, we're going to get 0.97. So we're going to the second row. We are plotting now 0.97 on the horizontal axis against 0.333 on the vertical axis. So take to the decimal place is 0.97 against 0.33. So this is where we have 0.95, and you know that each reading here is 0.0025. So 8 lines from here will give us 0.2, 0.02 plus this will give you 0.97. So have 1, 2, 3, 4, 5, 6, 7, 8. The 8th line here that is there. We'll move it up to where we have 0.33. This is where we have 0.3. So, and then 8th line should be around here. So this is the 8th line downwards. 0.33, 31, 32, 33. So this is the point where it should be at this point. So we'll go to the third row. So in the third, we are plotting 0.49 on the vertical axis against 0.94. So let's count out this one first, 0.94 on the horizontal axis. So here is 0.90, 16 lines from 0.90 will give us 0.04. Mind you that one line on the horizontal axis is 0.0025. So 0.0025 times 16 is 0.04. So count 16 lines here. From here to there is 10 lines. 11, 12, 13, 14, 15, and then 16. So we are right, 16. So this is 0.04 plus this now gives 0.94. So move it up to, we're plotting it against 0.49. This is where we have 0.4. So the 16 line is this 19, 18, 17, yeah, that's here. So 0.49 will move up. 49 will be close to 0.5, the line before 0.5. So this is where we'll have 0.49, the line before 0.5. So in the fourth row, we are plotting now 0.6361. Let's say 0.64 approximately against 0.903. So 0.64 against 0.903. So 0.64. So let's get it right. 0.90. 0.90 is almost at 0.9. Let's take a line after 0.9. That should give us 0. That give us 0.025. Approximately 0. That should give us 0.903. Approximately that, or 0.9025. So let's take it there. And against 0.664. So move it up. So 0.6 is up there. 64, 61, 62, 63, 64. I repeat myself. This is 6, 61, 62, 63, 64. A line. That is where we're putting it. A line after 0.9, going with 0.64. So having done that, we'll go to the final or the last point. So for this one, we're plotting 0.8599, approximately 0.86 against 0.76. So 0.86, each line here is 0.0025. So 4 lines, 4 times 0.0025 give us 0.01. So we're going to count 4 lines and add it to this. That gives us, this is 0.85, that gives us 0.86. So I have 1, 2, 3, 4. So this gives you 0.101 plus this gives you 0.886. We'll plot it against 0.76. We'll move up. This is 0.7, 71, 72, 73, 74, 75, 76. Yeah, that is here. 1, 2, should be on the 4th line. I repeat my second. 71, 72, 73, 74, 75, 76. Then this is 1, 2, 3, 4. The point should be here. So 86 with 0.76. So we join our lines. So we're going to say we're getting a negative graph, an inverse graph. So we join our line, the points to get the best point. This will give us 2 points only. 2 points, 2 points, but they take the middle points with this one scattered around it. So move, and then we'll move forward, and then we can take it up. So that is our line. So this side is bent, so we have to remove this line and correct the error here. The line is bent. So that why it's always good use a straight, use a longer ruler to avoid this error. So when you have done that, so the next is to find a slope. We'll take these 2 points here and these 2 points to get a slope. So we can draw a right angle triangle, cutting it, and then also cutting here. So to find the slope, so the slope will now become the change on M axis over this change on N axis. So that the gradient, we'll find the value here. The value of M here is 0.64. If you trace the vertical axis, then the value of M at the lower end is 0.33. Then you go to the horizontal axis and read out the value of N. The value of N here is, if you go down, that will be 0.97 minus the value of N here is 0.903, or let's go 903 approximately, or 90, since we're reading to 2 decimal places. So we can take it there, or I think we're approximately 0.9, okay, 03. We'll now subtract 0.64 minus 0. So we encountered a little mistake here. We want to correct it. So this graph is an inverse graph. So the denominator and the n axis, you reverse the order. Instead of 0.97 minus this, it becomes the smaller value but the bigger value. So it should be 0.97 0.0903 minus 0.97. That is what should be under 0.0903, the reverse minus 0.97. That gives us negative 0.067. So if you divide 0.31 by negative 0.067, we'll be getting negative 4.63. Negative 4.63 as our slope of the graph. So look at the remaining question. The remaining question says we should evaluate Q equal to 2WS. Q equal to 2WS from our experiment. So Q is 2WS. Remember that W is the width of the prism. So remember the W is the width of the prism that we measured earlier today. So the prism, the width is 6.5, we got that, centimeter, multiplied by the slope, which is minus 4.6. The slope is dimensionless because the slope is, I think, sine of an angle against cos of an angle. So we have no unit. So we'll multiply that. So we'll multiply that, we'll have our Q as negative 60.2, approximately 60.2 centimeter. That is the value of our Q, negative 60.2 centimeter. Our last question is question SV that says, state 2 precautions taken to ensure accurate results. What precautions should we take to ensure accurate results? One of the precautions is that the pin, I ensure that the pins are located vertically erect, so, and also at reasonable spacing. So those pins, P1 and P2, should be kept at a reasonable spacing. They should be kept vertically erect and then located at a reasonable spacing to avoid. And then I also avoided error due to pararas in reading the meter rule, the protractor, and the meter rule. Error due to pararas, and also in locating the image pin. So number 3, I ensured that there was adequate source of light for refraction. So these are the precautions that you observe in this experiment. So thank you very much for your time. Stay connected.